Okay, let's see this question here. So I will do number 3 for you. So question 1 to 6, find the critical region for the test statistic X, okay, representing the number of successes. Okay, so assume that it's all binomial distribution. So let's look at number 3 here. We have the null hypothesis that P is equals to zero point 0.4, and the alternate is not equals to zero point 0.4. This is definitely two tails, right? So it says here 2.5% on each tail because it's 5% alpha, and N is also given to you. Okay, so what I'm going to do is let's just draw out like this. So this is the first region, and this is my second region. I'm looking for this here. This here. So I can call this C1 and this C2, right? I even know that if you look at the binomial, we know the value of P, right? And this is 0 0.4, and you're saying that N is equals to 20. So let's just write that out. X has a binomial distribution, okay? N is 20 and P is 0 0.4, okay? So what do we do here? First of all, I can say that let's just try for X is less than or equals to, I'm now looking for this side first, this area, okay, for C1. Let's just say X is less than or equals to 5. Let's try 5 first. Let's see what do we get for the probability. Because we know that we want this region to be 2.5, right? This is supposed to be 2.5. Okay, so I'm going to look in the table, okay, binomial, and it should be CDF, and the binomial CDF, let's see, binomial CDF. So I am putting in the value as, hold on, let's see, binomial CDF. The trials is 20, and P is 0 0.4, and X value I'm putting in 5. So I got 0 0.1255. No, not this one. I want to go lower. Let's try X is less than or equals to, let's go with 3. Okay, so if I try 3, let's see what happens. So putting in 3, I got 0 0.1, sorry, 0 0.0159. This makes sense, right? So if you can check 4, 4 is about 5%, but 3 works. So I know that this has to be 3. So C1, my conclusion will be C1 is less than or equals to 3. This is my critical region, first on the left side. Now let's look at for the right side. So this side, I'm looking for this side. So for this side, I know that this is also 2.5%. Yeah, so 2.5%. Let's try probability that X is less than, sorry, this should be greater than or equals to, we know that N is 20, right? Let's go with maybe 15 first. So let's try 15. So I'm going to go CDF again. And then just change the X value. If you put in 15, so 1 is that. If I tried 15, I get 0.0000317. Okay. Can I go with maybe, let's try 14. Let's see 14. What do we get if it's 14? Okay, so if it is 14, I get 0.00161. Let me try 13. So we go with 13 now. If it is 13, you get 0.00646. Okay, kind of makes sense because this is actually 0.025, right? What if we go with 12? Because all this is fine, yeah? but we want the one that is actually close to 2.5. Yeah, let's try 10. Okay, let's go with 10. Let's see what do we get if we put in 10. 10 is 0.12, so we don't want 10. Okay, let's go with 11. So we look for 11. Mm-hmm. 0.056, still too much. So this is no, this is not what we want, not what we want. So let me see if 12 works. So if 12 doesn't work, my answer will be 13. Yeah, so let's see 12. Okay, so 12 gives me, let me push this back a little. Okay, 0.021. Okay, makes sense. Still less than this guy, right? So C2 is greater than, yeah, greater than or equals to 12. Okay, so this works, this makes sense. So my answer for the left side is this. For the right side is this. Okay, all right, move on. Let's see one more question here. Let me clear this. Okay, let's see number 7. So number 7 here says that you're supposed to also find critical region for the test statistic for Poisson distribution. So you see here that the null hypothesis is given to you, that lambda is equals to 4. The alternate is lambda is greater than 4, using 5% level significant. So what I need to do here is that I need to say that I'm looking for the left tail, and this is 5%, right? I want the critical region here so that my data will be rejected. So what I'm going to do is I'm going to say X has a Poisson distribution with a parameter of 4. Okay, so now I can try, let's say, probability that X is greater than or equals to, you can pick any number, right? So let's just go with distribution and Poisson CDF. Lambda is 4 and X value, let's try maybe 3. So 3 doesn't work. Let me go with, if you have a table, it will be very easy. I'm gonna pick a random number. Let's pick 10. So if I do 10, I will get 0.0028. Okay, let me try. This is too much, yeah. So let me go with maybe 8. Let me try 8. So I'm going with 8. So if I go with 8, I got 0.0213. Nope. Let me go with 6. Let me try 6. I get 0.11. So 6 doesn't work. So maybe 7. 7 should work. Let's try 7. Okay, 7 actually works. So 7 is 0.0511. Yeah. So 7 actually was here. It will come out a little bit. So I don't want 7 unless they say close to. Yeah. So find the critical region. It didn't say close to, but then we want it to be less than 5%, right? Sorry, greater than 5%. So let's say instead of using 7, I will go with this instead because this lies in the region that I'm looking for. So my C here should be greater than or equals to 8. Yeah, so this is my answer. I want this to be my C.